Welcome to a brand new video. Now exoplanet WASP 69. B has a tail, leaving a trail of gas in its wake. WASP 69. B is slowly losing its atmosphere as light hydrogen and helium particles in the planet's outer atmosphere escape the planet over time. But those gas particles don't escape evenly around the planet. Instead, they are swept into a tail of gas by the stellar wind coming from the planet's star. Hot Jupiters, like WASP 69. B are super hot gas giants orbiting their host stars closely. When radiation coming from a star heats up a planet's outer atmosphere, the planet can experience photoevaporation, a process in which lightweight gases like hydrogen and helium are heated by this radiation and launched outward into space. Essentially, WASP 69, these star strips gas from the planet's outer atmosphere over time. What's more, something called the stellar wind can shape this escaping gas into an exoplanetary tail. The stellar wind is a continuous stream of charged particles that flow outwards into space from a star's outer atmosphere or corona. On Earth, the sun's stellar wind interacts with our planet's magnetic field, which can create beautiful auroras like the northern lights. On WASP 69, B, the stellar wind coming from its host star actually shapes the gas escaping from the planet's outer atmosphere. So instead of gas just escaping evenly around the planet, strong stellar winds can sculpt that outflow in tails that trail behind the planet, said lead author Dakota Tyler, an astrophysicist at the University of California, Los Angeles, likening this gaseous tail to a comet's tail. Because this tail is created by the stellar wind, however, that means it's subject to change. If the stellar wind were to taper down, then you could imagine that the planet is still losing some of its atmosphere. But it just isn't getting shaped into the tail, Tyler said. Adding that, without the stellar wind, that gas escaping on all sides of the planet would be spherical and symmetrical. But if you crank up the stellar wind, that atmosphere then gets sculpted into a tail. Tyler likened the process to a windsock blowing in the breeze, with the sock forming a more structured shape when the wind picks up and it fills with air. The tail that Tyler and his research team observed on WASP 69b extended more than 7.5 times the radius of the planet, or over 350,000 solar miles. But it's possible that the tail is even longer. The team had to end observations with the telescope before the tail's signal disappeared. So this measurement is a lower limit on the tail's true length at the time. However, keep in mind that because the tail is influenced by the stellar wind, changes in the stellar wind could change the tail's size and shape over time. Additionally, changes in the stellar wind influence the tail's size and shape. But since the tail is visible when illuminated by starlight, changes in stellar activity can also affect tail observations. Exoplanet tails are still a bit mysterious, especially because they are subject to change. The study of exoplanet tails could help scientists to better understand how these tails form, as well as the ever-changing relationship between the stellar and planetary atmospheres. Additionally, because these exoplanetary tails are shaped by stellar activity, they could serve as indicators of stellar behavior over time. This could be helpful for scientists as they seek to learn more about the stellar winds of stars other than the star we know the most about, our very own Sun. WASP-69 B is losing a lot of gas, about 200,000 tons per second, but it's losing this gaseous atmosphere very slowly. So slowly, in fact, that there is no danger of the planet being totally stripped or disappearing. In general, every billion years, the planet is losing an amount of material that equals the mass of planet Earth. The solar system that WASP-69b inhabits is about 7 billion years old. So even though the rate of atmosphere loss will vary over time, you might estimate that this planet has lost the equivalent of 7 Earths in mass of gas over that period. A team of scientists led by Dakota Tyler of the University of California, Los Angeles published a paper in January 2024 on their discovery. WASP-69b's escaping envelope is confined to a tail extending at least 7 up. In the journal, the Astrophysical Journal. The observations described in this paper were made by Keck Nurspec. Nurspec is a spectrograph designed for Keck 2